My name is John Orchard with the Department of Energy, Office of Nuclear Energy. Our topics, our webinar, our NEAP topics are FC-4.1 for disposal research, and FC 4.2 and 4.3, and we deleted 4.4, so we just got 2 storage and transportation. And I'm John Orchard, the federal manager, and Dave Sassani is our national test director for the national labs. And I think Dave's on the call as well. And we also have Prasad Nair, who is looking after the FC-4.1 disposal research topic. So if you want to go to the next slide. Okay. Quick overview, our Office of Nuclear Energy mission. I've outlined it there. And our Office of Spent Fuel and Waste Disposition is to identify alternatives and conduct scientific research and technology development to enable storage, transportation, and disposal of spent nuclear fuel and waste generated by existing and future nuclear fuel cycles. So next, I've got a list of the national labs that work with us on this mission, and there they are. Got 9 labs there listed. The next slide. Our spent fuel disposition, we call it our grand challenge, is to provide a sound technical basis for the safety and security of long-term storage and then the transportation and disposal of the spent nuclear fuel and waste from the nuclear energy enterprise. And it's important because it supports the establishment of SNF, spent nuclear fuel management and disposition pathways. Next slide, please. Our research needs in disposal are to provide a sound technical basis for assurance that the U.S. has multiple viable disposal options available when national policy is ready. We also have to identify and research generic sources of uncertainty that challenge the viability of disposal concepts. We have to increase the confidence and robustness of the generic disposal concepts to reduce the impact of site-specific complexity. Once we make a specific site selection, we want to have our homework done in advance to specify it to the site-specific complex. We want to develop the science and engineering tools required to address these needs above. In the storage and transportation area, we want to develop the technical bases to demonstrate spent fuel integrity for extended periods of time. We want to develop the bases for fuel retrievability and transportation after extended storage, and for also transportation of high burnup fuel, which is becoming more the norm now than I guess the low burnup fuel. Next slide. And here are some graphics or cartoons of what we do. On the top there is under repository, we got barriers for waste isolation, such as natural barriers in saturated or unsaturated zones and in reducing or oxidizing environments. And then we also have the engineered barriers, such as backfill, the actual container, overpack, etc. And then finally the waste form, which could be also glass or ceramic, I guess if it's a waste, a high level waste. Our generic geologies, we're looking at clay, the clay or shale. We're looking at salt geologies. We're looking at crystalline rock, and we're looking at alluvial media. Next slide, please. And storage and transportation, we got the fuel, which includes the pellet, the cladding, and the hardware assembly, the assembly hardware. We got the casks and their internals. Then we have the storage locations, the ISPACs, which include pad rebar and the physical protection. And then we have monitoring systems, which we're looking at is for remote inspections, possibly in-package sensors, and security monitoring. Next slide, please. We're looking for research proposals for programs supporting R&D proposals, which are the university-led projects up to $800,000 awards for up to 3-year duration. And we're soliciting them the 3 areas: the disposal, the earthquake response, which is for storage and transportation, and for particular deposition for storage in particular. And we'll go into more detail in the next couple of slides. So next slide, please. For the disposal topic, we're looking to develop new and improved concepts, data, and models to demonstrate total system performance of the permanent disposal of spent nuclear fuel and high-level radioactive waste. And this should apply to a variety of generic deep geologic repository concepts in clay, shale, salt, crystalline rock, and alluvial media. The research should include one of the following strategies, I guess. First is barrier material development and experimenting, testing, investigating, characterizing methods, advancing the methods. Then data quality improvement and model enhancement, focusing on sensitivity analysis, uncertainty qualification, and reducing uncertainties. Research should address one or more of the following interest areas: improved understanding of waste package failure modes, improved data and understanding of aqueous speciation and geochemistry of radionuclides, improved understanding and new concepts for engineered and natural barrier systems, and new concepts or approaches for alleviating post-closure criticality concerns. Next slide. Our FC-4.2 topic is earthquake response of spent nuclear fuel in dry storage facilities. And where we're at is the DOE is evaluating the seismic loads that spent nuclear fuel assemblies might be subject to during extended storage and transportation by applying earthquake loads to a full-scale mock-up of a dry storage canister containing surrogate and dummy SNF assemblies on a shaker table. So we're going to do an actual test of a mock-up of a full-scale mock-up of a spent nuclear fuel canister. And so we're looking for research proposals for developing innovative techniques to analyze the stresses and strains on all structural components of the SNF assemblies based on the data collected during the empirical tests that we are running. The DOE will run the tests, and we're looking for research proposals to analyze the data. Universities must develop or adapt innovative approaches for computational modeling and simulation, analyzing large volumes of empirical data, developing novel transfer functions for sliding and rocking, validating high fidelity computational models, and identifying risk and mitigating the risks, as well as recommend additional empirical tests or future work that might be suggested. And so next slide. Our other storage and transportation topic is experimental validation of particulate deposition mechanisms on dry storage canisters. And here we're evaluating the susceptibility of spent nuclear fuel dry storage canisters to stress corrosion cracking induced by chlorine salts precipitated in marine environments. The storage canisters will be stored generally outside in the isthmuses, and in marine environments we're investigating the chlorine salts from the environment, from the air, precipitating onto the stainless steel canisters. So to support, and the effects it might cause. So to support this study, research proposals are sought for designing and performing laboratory and small scale experimental analyses and interpretation of these 10 of the most likely particulate deposition and resuspension mechanisms under the relevant conditions. And the mechanisms are aerosol droplet evaporation, Brownian diffusion, aerodynamic deposition, gravitational settling, thermophoresis, turbophoresis, Safman lift, diffusophoresis, Stefan flow, and electrophoresis. The test should look at the separate as well as combined effects of these mechanisms and assess the relative importance of each under the different conditions. So next slide, please. So I guess that was my presentation. And so does anybody have any questions? Are there any questions?
Hi, John. We do have a few questions. I'll read the first question. I believe they are asking if the U.S. currently has any transported or disposed spent nuclear fuel.
Does the U.S. have any transported or disposed spent nuclear fuel? We do. The government, well, utilities do a lot of transporting of spent nuclear fuels from their production sites to their storage sites. The U.S. government has done limited transportation. As far as disposing of it, I offhand can't think of anywhere that we've disposed of like long-term disposal of spent nuclear fuel.
For example, another question is collaboration with EPRI allowed?
Yes, we sort of encourage collaboration with other entities, yes.
Another question we have that also deals with FC-4.2. And that question is, pit and crack propagation rates, is this part of FC-4.1 and 4.2 or 4.3 with uncertainty analysis?
Well, it wouldn't be part of any of them. It was part of last year's topics, but the 4.1 deals specifically with the disposal of the waste, and Pit and Crack is looking at degradation of the canister integrity, which we've been looking at under storage and transportation. And it wouldn't fall under either 4.2 or 4.3. So although we have been very interested in that in the past, it's not part of this year's proposal solicitation.
Okay, thank you, John. We have another question specifically for FC-4.2. Would there be more specific information on the physical test setups with the FOA?
Yes, we've got a very extensive description of the physical setup, and we can provide more if needed. And certainly, once an award is made, there'll be a lot more information available to the awardee.
Okay, we have a question for FC-4.3, and that question is there any specific code that should be used to compare the experimental data regarding particle transportation and so on?
I think what we're looking for there is for the researcher, the grantee, to make that selection himself. I think we want to get the empirical data from the grantee and use that in our own codes. So I think we're looking mostly for the, like I say, the empirical data, and we'll do the we'll put it into the model to validate the model. But it's our model we're using. If the grantee has or wants to use a model of their own, they could select that.
The next question is for FC-4.3. It says small-scale experiments are encouraged. Could you give an example of these small-scale experiments?
Not specifically. That's again what we're asking the grantee to do, is to develop the lab experiments to generate the data for those 10 mechanisms that we mentioned. So it would be up to the grantee to develop that.
Okay, thank you. We have a further follow-up question to the FC-4.2 question, and that is, at what point could we reach out to get more information about test configurations?
Well, first of all, we put a lot of data into the FOA, and I think we already, just in the last few days, issued a draft FOA, didn't we? And there's about 2 pages of information there. There's a lot of detail.
Whatever information we need to supplement the funding opportunity call, John will post that out publicly for all participants to be able to see.
Okay, good. Yeah, I was after an award's been made, we'll provide whatever level of detail you want. But until that time, yes, we've got to be aware of the procurement rules. Okay.
Okay, thank you, John. Other questions that will be answered will be posted to the Q&A page on the NEUP website at a later date.
Yeah. And are they sorted by topic?
Those questions are sorted by topic, yes.
Okay, so people interested in FC-4.1 can just go straight to FC-4.1 and find out all the questions that have been asked and what the answers are.
That is correct. Okay. Thank you very much, John. That will conclude this webinar, and it will conclude day 2.